Hey guys, today we're going to be going over graphing motion. We're going to be looking at graphs again. It's just a refresher, and as you guys are refreshing yourselves, you are going to be filling out these doodle notes here. All of this stuff you'll be able to find in this PowerPoint except for what you're going to draw here. As we go through the PowerPoint, I'm going to come back here and you guys are going to include what I include here. Please make sure you find definitions for those 4 items there. You do need to fill in these boxes on the graph. You will need to write a definition for slope. Tell me what low slope and a steep slope means. Don't forget to write your formula for speed and fill out each of these things here. All right, telling me what they mean. Okay, let's go ahead and get started. I hope you guys are finding this stuff pretty easy because it really is just, interpreting graphs, which is something that you should have done in your math classes by now. So let's go ahead and take a look at our PowerPoint. Remember, describing the motion of an object is boring if you use just words, but we're going to be using graphs. Graphs are great because they're more revealing. A graph can tell you at a glance what something is doing or what is happening or what the information means instead of sitting there and having to try to figure out what's in a data table. So we're going to be graphing motion here, and motion, which is on your worksheet, is a change in position determined by the distance traveled in a certain amount of time. Distance traveled, where it's a change in position. By plotting distance against time on a graph, you can kind of see a journey on a graph, and a distance time graph shows how far an object has moved in a certain amount of time. And when we look at distance traveled in a certain amount of time, it actually tells us the speed of an object. Right? So it can also show you something like velocity. Remember, on our graphs we can have lines that slope up or lines that slope down. These sloping lines can tell you about the speed depending on its slope, or it can tell you about the direction if something's moving away from start or back towards start. So let's look at the axes here and make sure you fill this out on your graph. Here on the y-axis, we have distance. Distance always goes on the y-axis, and time always goes on the x-axis. When you're looking at a distance time graphs, your numbers increase as you travel away from the origin. So the further up you go on distance, that means the farther away the object is. The further you go on the x-axis, that means the more time has passed. Distance goes vertically, so the higher up the graph you go, the further we are from start. And because the y-axis shows you distance and the x-axis shows you time, if something is not moving, what that means is it has a constant distance. So as you are plotting these points here, so if we had time equals 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, and you plotted those points here, at 1 second it was this far away, at 2 seconds it was this far away, 3, 4, 5 seconds, you can see here that the distance is remaining the same each time interval, and that's why a flat line shows you that something is not moving. Horizontal line means an object is stationary. But if something is moving at a steady speed, it means that we expect the same increase in a distance in a given time. So what that means is that for every interval of time that passes, the object moves the same amount of distance. So when we plot this on a graph, we get a straight line, right? Time is increasing to the right and distance is increasing steadily with time. A straight line on a graph means that an object is moving at a constant speed. The speed is not changing. And you can have different steepnesses of line, and these two lines will show you that objects are moving at different speeds. The steepness of the line is called the slope, and a smaller slope or a less steep line means that the object is moving slower. So on our notes here, you should have filled in motion, you should have filled in slope, you should have filled in here and what a distance time graph shows. You also should have filled in horizontal line means and a straight line means. Right? We're going to draw two lines on our graph. We're going to draw one straight line here and another straight line here. Which one of these guys is going faster, the first line or the second line? Yep. So please go ahead and draw and label these two lines on your doodle notes. All right, so the faster one is the steeper, and what that means is it covered more distance in less time. If you're looking here, both of them traveled the same distance. They reached the same point on our y-axis, but it actually took the object that made the yellow line less time in order to do that, which is how we know that it moved faster. Steeper slope indicates a higher speed, moving more distance over time. So speed is the rate at which an object is moving, and we used our formula before. Speed equals distance divided by time. This particular graph here shows you a change in motion. For the first part of the journey, the object traveled slow, and then it started traveling faster. Overall, because the graph is not one straight line, it shows you a changing speed. But for each interval here, for interval number 1, this is a constant speed because it's moving, it has a straight line. But then interval number 2 is also a constant speed, moving in a straight line. Right. Here at this point, the object suddenly increases its speed, which is what causes the line to bend. We can have a curved line. A curved line means that speed is changing. For this one here, it starts out slow, gets faster, and then gets faster at the end. Let's take a look back at our doodle notes. We should have written what a low and a steep slope mean. You should have filled out the speed equation. You should have filled out what curved line means. Let's continue. So this curved line here, given time, the distance of the object gets bigger and bigger over time. This means it is accelerating. So a curved line is acceleration. And acceleration means a change in speed or direction. Here for this distance time graph, it's just showing you a change in speed. Right. This particular graph shows you 3 parts of the journey. Where is the graph showing motion that is stopped? A, B, or C? That is B. The object is not moving. At what point is it moving at a constant but fast speed? That would be C. and that would mean that A is traveling at a constant slow speed. This graph here is another graph of motion that shows different stage. Stage 1 is the dark blue line, and this is showing a constant speed at a relatively high rate. And stage 2 is this cayenne color here, and it is moving at a slightly slower rate. But stage 3 here is moving at a constant medium speed. But I want for you guys to notice that this magenta line here is sloping downwards. The slope of the line indicates its rate of change, and speed can be estimated by the line, whether it's going faster or slower. Right? But in stage 1 and stage 2, the blue and cayenne colored lines, these guys are showing that the object is moving away from the starting point. It's sloping upward, so it's moving away. And a magenta line here that is pointing downwards indicates that the object is moving back towards the starting point. All right. Let's go ahead and add that to our graph. We're going to say here that this one is away fast. And we're going to add another graph here, or another line that says back towards the starting point. Going backwards, basically. All right. Now remember, the steeper the line on a distance time graph, the faster the object's speed is, and a curved line indicates that the speed is changing. Lines pointing upward indicate the object is moving away from the starting location, and lines pointing downward indicate that the object is moving back towards the starting location. If you can remember these 4 points right here, you understand graphing motion. All right. Let's head back to our doodle notes here. We're going to add 1 or 2 more graphs. We need to understand that the curved line means changing speed. Which is acceleration. And then a flat line is no motion. Standing still. Right? By this point, you should have filled out everything, including these bottom ones here. The PowerPoint is on Canvas if you need to go back and take a look at any of this to fill it in. But please make sure that you have everything. This is like a cheat sheet to understanding distance time graphs. Right? I hope you guys are having a great day, and I hope you have an awesome week. I know everybody's looking forward to the holiday break coming up soon, and I look forward to seeing all of you guys back on campus when you return in January. Take care. Have a great day.